Algebra I, 13.4b, the discriminant. We've been talking about quadratic equations, and if you have not seen these last 5 videos and you don't know about these topics, squares of binomials, completing the square, solve quadratic equations when the a is equal to 1 or when it's not equal to 1, or if you've never been introduced to the quadratic formula, you may end up being confused by watching this video. And there's links in this video's description that you could just click on these videos, watch them real quick, and come back. All right? You need to fill in what you don't know before you move forward. And the quadratic formula is great for solving special cases that may not be solved using the methods we've learned so far. So check this description. Watch them real quick, okay? And so far we've had 2 real number solutions for our quadratic equations. Well, sometimes there's only going to be 1 or no real number solution. The discriminant, the expression under the radical sign in the quadratic formula as b squared minus 4ac, can help us figure out how many real number solutions. See, it's right here? It's going to help us figure out how many real number solutions there are for a quadratic equation. All right? So I want to show you what I've got here. I've got a table that I've made. And in this problem going across, there's 2 solutions. In this one going across, there's 1 solution. And in this one, there's no real solutions. Okay? So let's take a look at this. Here's our quadratic formula. And you can see the discriminant is the thing underneath this radical sign. Okay? And that's going to help us a lot. All right? We've got solutions as the quadratic equation. We've got our discriminant. And we're going to graph these as a function. Okay? Here's the equation, but it's written in function form. See? It's just with a y, all right? So, what we've got is, for our first problem, is x squared plus 2x minus 3. We're going to plug these values into here, into the quadratic formula. And to find out what goes underneath this radical sign, we're going to use the discriminant, okay? We'll plug the values into b squared minus 4ac to find out what goes underneath that radical sign, all right? So we're going to kind of go in a circle, all right? We're going to kind of put it all in. So the first thing we've got is we have to have a negative b here, where our b is a positive 2. So we need to make it a negative 2. So we do. It's right here. Then we've got plus or minus. And we need to fill in underneath this radical sign, the discriminant. So we've got b squared minus 4ac. So b squared would be 2 squared, wouldn't it? See? Because that's b. Then we've got our minus 4. That's in every single one. And now we need to multiply it by 1, which is the coefficient for our second degree term right here. There's an invisible 1 there, isn't there? And by c, which is a negative 3. See? We do our math, and we get 2 times 2 is 4, plus a 12 is going to give us a positive 16. So a 16 is going to go underneath this radical sign. Well, square root of 16 is 4, isn't it? And our denominator is 2a. A is a 1, isn't it? So we've got 2 times 1. So now we've got negative 2 plus 4, which gives us a positive 2, over 2. Well, 2 over 2 is a 1. And for the minus, that's the plus, see plus or minus, we've got negative 2 minus 4, which gives us a negative 6. A negative 6 over 2, whoops, is a negative 3, isn't it? So we got 2 real number solutions. We've got a 1 and a negative 3. Now check this out. We've got a 1 and a negative 3. That 1 is right here, and that negative 3 is right here. When the value of the discriminant is a positive, there's 2 real number solutions, and we can do them with a s with a little 1 subscript like this for solution 1, and an s2, little 2 subscript right here for solution 2. That means it touches the x-axis twice, and it did. 1, 2, at 1 and negative 3. And remember, the vertex can be found with negative b divided by 2a. We did that a few videos ago. If you don't know what I'm talking about, you shouldn't be in this video. But there will be a link so that you could go watch it, okay? So, that was back in chapter 12, I believe. So, we use this negative b divided by 2a to find where the vertex is. And negative b would be negative 2 divided by 2a. A is a 1. So we have negative 2 divided by 2 times 1. Well, negative 2 divided by 2 is a negative 1. So we know the vertex is at negative 1, and we know it goes through the points of 1 and negative 3 on the x. So we could make our parabola, couldn't we? And you know what else we know? We know it opens upwards because this is positive. We don't have a negative there, do we? We learned that also, didn't we? All right, let's look at this one. Now, we're going to plug the values into the formula and then use the discriminant again, okay? So now we've got 0 equals x squared plus 4x plus 4, and we need to plug these in to our quadratic formula. So we've got our b right here, that's a 4, so that's going to be a negative 4, see, for negative b, and we need to put something underneath this radical sign, so we need to do the discriminant, don't we? So we've got our b squared minus 4ac, okay? That's going to come underneath here. Well, b squared would be 4 squared, wouldn't it? That would be 16. And our a is a 1, and our c is a 4. So we do the math, and we get 16 minus 16, which is a 0. So we're going to put a 0 underneath that radical sign. And we have to do 2 times a, and a is a invisible 1 buddy, right? So it's going to be 2 times 1 is 2. So now, when we go to simplify this, we get negative 4 plus or minus the square root of 0. So we get negative 4 plus 0, negative 4 minus 0, which doesn't matter. It's the same thing. Negative 4 over a 2 is a negative 2. So we have one real number solution for this one. All right? It's set to a 0. We have one real number solution. When the value of the discriminant is a 0, there's one real number solution. And you know what? It touches the x-axis once. When it had 2 real number solutions, it touched the x-axis twice. Now, because it equals 0, it's going to have 1 point where it touches the x-axis. And if we do that vertex formula of negative b over 2a, it'll come out that exact point right here at negative 2. Isn't that something? All right, let's take a look at this last one down here. We've got x squared plus x plus 5. Well, now these both have a 1, don't they? And we use the quadratic formula to plug everything in right here, okay? So our b is a 1, so we've got a negative 1 because it's supposed to be negative b. And we need to fill in the discriminant, don't we? So our b is a 1, so we've got 1 squared. That's the b squared, see? And we've got our minus 4 times a times c. Our a is a 1, and our c is a 5. So we've got 1 times 1 is 1, and we need to subtract a 20. That gives us a negative 19. Okay? When we do all this math, we get a minus 20, which is a minus 19. That's a negative number. That means we're putting a negative number underneath the radicand. See? Under the radical symbol. And we can't have that, can we? You can't put a negative number under a radical sign. So there's no real number solutions. See? There's no x. Now because of that, and it came out negative, when the value of the discriminant is negative, then there's no real number solutions. And guess what? It doesn't touch the x-axis at all. So this guy's kind of floating in the air. Here's the x-axis, and it's floating way up in the air. Now, we can find out where the vertex is. It's at negative half, so it's in between negative 0. It's in between 0 and negative 1. So we know that's the axis of symmetry, and that's where the vertex is, but it's not touching the x-axis at all because the discriminant came out as a negative. See that? So when it's a positive, like this 16, then there's 2 real number solutions. and it touches the x-axis twice. When there's a 0, then there's one solution, and it touches the x-axis once. When it's a negative, there's no real solutions for x, and it doesn't touch the x-axis at all. The x value for the axis of symmetry can still be found, but the actual parabola does not touch the x-axis, okay? Now, one of the things I want you to keep in mind is when there's a fraction bar, it's also called a vinculum. When there's a fraction bar, you have to remember to simplify above it and below it before you do any division, because fractions are little division problems, right? So we would do 2 times 2 is 4, and 4 times 4 is 16, and then we would divide it to get 1/4, okay? All right. The other thing I want you to keep in mind is when you've got a quadratic equation that's set to equal 0, when the graph crosses the x-axis at 0, all right? So if our equation equals 0, okay, when we do this actual quadratic equation and it turns out that the answer is a 0, x equals 0, that means that it crosses the x-axis at 0, okay? The solution to the quadratic equation is the x-coordinate of any point where the graph crosses the x-axis. So if our quadratic equation equaled 4, that means the graph crosses the x-axis at 4. See? If it was 8, it crosses it at 8. If it was -2, it crosses it -2. See? All right. So to find the value of the discriminant, to find the number of the solutions, what we do is we take our equation right here, and here's our discriminant, b squared minus 4ac. We plug in the numbers into this formula for the discriminant, and we get, there's a 1 here, isn't there, for this negative x? So for b squared, we get -1 squared minus our 4 times a times c. See? Times 1 times 2. When we do the math, -1 times -1 is a +1, and we take away 8, we're going to end up with a -7. So the discriminant answer is negative, so there's no real number solutions, and it won't touch the x-axis, will it? Just like our bottom one that had this -19, so it's not going to touch the x-axis, and there's no real solution, okay? No real number solution for this one, all right? Let's take a look at this one. It's got a coefficient of 3. Now, we learned before in the other videos, oh, we got to divide each term by 3, and we got to do all this. But watch what happens when we use the quadratic formula. We do less work, all right? This one's not even in standard form, is it? So we can rewrite this equation to put it in standard form, and you know how to do that, right? What we do is we take this -2x here, and we add 2x to each side. So that creates a 0 pair here. So now we've got 3x squared plus 2x on this side equals a 7. And then we take the 7 away from each side. So now we have a -7 on this side and a 0 on this side. And now it's in standard form. So now we've got it like this, and we use our discriminant. And we plug in our values. Our b is a 2, so we've got 2 squared minus the 4. And we've got a 3 and a -7. We do our math, and we get an 88. So because the answer is positive, we know there's 2 real number solutions, and we know the axis is touched 2 times. The x-axis is touched 2 times, isn't it? See? Oh, I know this is a lot of information, and some of you may have to watch this video twice, all right? Which is no big deal. No big deal at all, all right? 14, 15 minutes of your life to understand something, that's a piece of cake. That's not even an entire show on TV. It's just a few commercials, right? All right. So our next video is going to be 13.5a. We're going to actually solve some rational quadratic equations. And of course, all those links are in this description. All you've got to do is click on them. There's a lot of links. You can go through the list and just click and watch the videos that you think you need, okay? Maybe you can open it in a second window so that you can keep going back to this same list to watch the next one, all right? So you don't lose your place, all right? Okay, let's solve some rational ones. I'll see you later. Bye.